Okay, let's up the ante a little bit and find the domain of a composite function in which you have a radical in the denominator. So we're going to find f of g of x first, and then we'll find the domain of that result. So I'll do this in a blue so you can see my work. F of g of x is the same thing as f of the square root of x minus 5. We're going to put the square root of x minus 5 into 2 over x. So everywhere we see an x, everywhere we see this x, we're going to put that square root of x minus 5. And now we have to find the domain. So this is f of g of x, right? There you go. And now what's the domain? Well, because we have a radical, x minus 5 has to be non-negative. So we'll write that down. Must be non-negative because of the radical. And I'm writing this down because this is a tricky one for some students, so I want to make sure that you don't miss why we're doing what we're doing. The other thing is that x minus 5, the square root of x minus 5 is in the denominator. So x minus 5 cannot equal 0, and that's because of the denominator. So non-negative means greater than or equal to, but because it can't be equal to 0, it's just going to be greater than 0. So therefore, I'll write this in red, therefore, x minus 5 has to be greater than 0. So we add 5 to both sides, x is greater than 5, and in interval notation, we have 5 to infinity, written with open intervals, and that's our answer. Okay, we can try another one. If you want to try this one on your own, go ahead and press pause, and then when you're ready to reveal the answer, press play. Okay, if you've pressed pause and you've joined us, I'm going to reveal the answer right away so that you can see whether or not you got it right. This one is negative infinity to 1/2 with an open interval. So now I'm going to show you how I got that. F of g of x is equal to 4 over the square root of 1 minus 2x. And then going through what we did in the previous problem, we know that the radicand, 1 minus 2x, has to be non-negative, but because it's in the denominator, it cannot be 0. So 1 minus 2x has to be greater than 0. We want to keep it positive, but not 0. I'm going to subtract 1 from both sides. And now when I divide both sides by negative 2, so look at my work, negative 2x divided by negative 2, I have to flip the symbol, is less than negative 1 divided by negative 2. So the negative 2's cancel out, and x is less than positive 1/2, which gives us our answer, negative infinity to 1/2.